Okay, in this video, we're going to be writing this equation for the piecewise function here. So we have three different pieces. It's pretty obvious with the three different colors. If it is not so obvious, you may want to kind of just trace over the functions with different colors just to make it stand out. This first piece down here in blue, the second piece in red right here, and then the third piece right after that slope changes for the red turns into green. So those are the three different pieces that we're going to look at. After you identify the three different pieces, I like to go and start off by figuring out the different domains. So I'm going to go ahead and do that next. I always like to color code, so I'm going to keep switching back and forth. So my blue piece, we're going to have an equation, then if, and then I'm going to have an inequality. So just like domain, it's going to start off with my x value right here. This x value is -2 because my grid is counting by by 2's. Because this point on the left is a solid dot, we want less than or equal to x. On the right side is just less than, because it's an open dot, 1. So that's the first domain. Second domain for the red piece, so we're going to have an equation. If my red piece starts at the x value of 1, it's a solid dot, so less than or equal to x. And then at the other end we have a solid dot as well, so less than or equal to, and the other x value there is 5. You can see they labeled the ordered pair there. Finally, for the green piece, once again we have an equation. If we're starting at 5 for the green piece, remember x values here, and since we already used the x value of 5 for the red piece, we're not going to include it here, even though it does give us the same value. And then this green piece ends at the x value of 8. So less than, and it's a solid dot, so equal to 8. So there's the domain set up for each of the different pieces. Now we just have to write the equation for each piece, and we're going to do that in y equals mx plus b form. So, starting with the blue piece, we need two things for the blue piece. We need the slope and the y-intercept for the blue piece. Slope, we're going to use rise over run. So just pulling out some points. I'm going to use this one, and I guess I'll just use this one down here because they are clear points that I can definitely use. Sometimes if it counts by different things, it can be a little bit tricky to do rise over run. But if I start with my point on the left, I'm rising 2, 4, 6, remembering that it's counting by 2's. And then I run 2. So 6 over 2 is 3. And for my y-intercept, it's that point that I already plotted, which is at -4. Which means the equation for this piece will be y equals m, so 3, x plus b, or -4 in this case. The y equal to part will be taken care of by my piecewise function, f of x equals. So piece 1 is done. Piece 2 in red. So if we look at that, we need slope, or m, and our y-intercept of b. So with this one, remember that it's counting by 2's, so each of those points are actually in the middle of the grid. But if we look at this, just doing rise over run again for slope. So I go up to 4. And I go over 2 to the middle and another 4. So 4 over 4. You can also calculate slope with the y2 minus y1 over x2 minus x1. And sometimes that is necessary depending on how the graph looks and what portion of the graph you can actually see. 4 over 4 though simplifies to be 1. And then for our slope, our y-intercept here, well, we can't see the y-intercept on this graph, so we can do this in one of two ways. We can do it algebraically, or depending on the graph, we can kind of just extend the graph and figure out what the y-intercept is. Since we already know our slope is 1, we go up 1 and over 1, we can work backwards and go down 1 and back 1. So this would be where our y-intercept is if we were to extend the graph, which is at the y value of 3. Again, depending on the graph, that may be hard to do, especially if the graph would be a fractional y-intercept. So at the end of the video, there will be another just additional video to do it algebraically. Refresh memory on that. But now that we have both pieces that we need for the equation, we just have to fill it out. So y equals mx plus b. So y equals 1x plus b, or plus 3. And remember, 1x is the same thing as x, so we don't actually need that there. And the last piece is a horizontal line, that last piece in green. So horizontal lines equations is just y equal to a number. So we don't actually need to find slope. The slope would be 0, not rising at all. So we just need to figure out what that number is. And if you extend the line, that segment, you would see that is y equal to 8. Which means this last piece is just the number 8. And there we have it, the piecewise function for this graph. Okay, in this video, we're going to be writing the equation for the piecewise function graph below. The first thing I always recommend doing is identifying the different pieces for the piecewise function where it changes slope or direction. So I'm going to just highlight over the different pieces in different colors. So it looks like this is my first piece here. And then my second piece picks up where it leaves off and then kind of continues. So that's the first thing I always recommend doing with piecewise functions when you're trying to write the equation. Second thing I do is I write out the domain. So f of x equals, we're going to have some sort of equation if, and then some sort of inequality. Then same thing, I'm going to go back now and do the inequalities. We only have 2 pieces on this example. So for that first piece, if you look, it doesn't have a starting point. It continues off the side of the graph. So it would range from negative infinity, less than x, and for the right endpoint, it stops at the x value of -1. Remember, these intervals here are x values. So -1 is where we stop, and it is an open dot. So less than -1. So that's the inequality for the first piece. For the second piece, our graph is starting right here at the x value of -1. It is a solid dot there, so less than or equal to x. And then it runs off the side, so we're going to be assuming it keeps going and going and going all the way to infinity, since we're on the positive x side now. Now, a lot of times, if this is like a standardized test, you may not see the answers written out like this. Instead, they may write the inequalities without the infinities. So they would turn the first one into x less than -1, and they would turn the second one into getting rid of the infinity and just rewriting the x first. X is greater than or equal to -1. This is more commonly how you'll see the inequalities, but both are correct. Now that we've identified the domain of each piece, let's go back and write the equation for each piece. So I'm going to start with the one highlighted in green. That is a horizontal line, and the equation for a horizontal line is y equal to some number. In this case, that number is the y value of 1. So our first piece, the equation is y equals 1, which means we just have to put 1 for our piecewise function. Second piece, highlighted in red, we're going to have to use y equals mx plus b, needing our slope and our y-intercept. For slope, rise over run, I'm just going to choose 2 points. I'm going to use this one and this one. We rise 2, and go over 1. 2 over 1 is just 2. My y-intercept there is -1. So we have both pieces we need for for the equation, and our equation is y equals 2x plus b, or -1. And there we have it, our piecewise function.
In this example, we have a word problem. Your cell phone plan costs $35 per month, gives unlimited talk, 500 text messages per month, and no data plan. After 500 text messages, it costs 10 cents per text message. Write an equation for a piecewise function that represents a situation. So just like the other ones, I'm going to have to break it apart into the different pieces. But just first of all, I'm going to talk about the variables. So x in this case, I see 2 different pers. I see the per month, and I also see per text message. One of those has to be x. In this case, it's going to be the per text message. X is going to be the number of text messages. The reason being is because without knowing the number of text messages, we can't calculate the total cost per month. So x has to be that first variable, and then y would just be the cost per month. Or the total, at least. And since we're dealing with piecewise functions, I'm going to actually change y to f of x instead. Doesn't matter, it's the same thing. I just prefer using f of x for piecewise functions. Okay, with that being said, let's go ahead and break it apart into the separate pieces. So the 2 pieces that we're going to have is the base plan, which is the $35 per month, giving the unlimited talk, 500 text messages per month, and no data. The second part is after that 500 text messages. So going through, just like the other ones, we're going to save the equation for later. The condition here, for the first bit, remember to think about the upper and lower bounds. So the lower bound here is what is the minimum number of text messages we could send in a month. X is the number of text messages. So what is the minimum number? Well, minimum number is that we send 0 text messages. Most word problems, if you have a inequality associated with them, you need to exclude anything below 0. Most real-life problems don't deal with negative numbers. So 0 less than or equal to x. And what is the maximum number for the base plan? Well, 500. We have exactly 500 text messages to use, so we can include the 500. The second piece is after we have used our 500s. So if the lower bound would be 500 less than x less than, and there really is no upper bound. I mean, logically, you cannot send a certain number of text messages, and with the 10 cents per rate, or 10 cents per extra text message, there's a limit that you can spend for your bank account, but mathematically, there is not an upper limit besides what you can physically send in the month or run out of money. But we don't have those conditions, so we can't really say as an upper limit. You may also see the inequality written as x greater than 500. Now for the equations. So let's go back to the first one. The first one is the flat rate, $35 per month, unlimited talk, 500 messages. So there's no variable involved with that because it's just a flat rate per month. The second one, we still have to pay that $35 if we go over. So if we go over our 500 messages, we're paying the $35 plus 10 cents per text message. Now, normally we would probably put 0.10x, right? Normally that's how it goes with a lot of the word problems. Per x, per typically tells us we're going to put an x there. However, that's not the case in this particular situation, because remember that the $35 already counts for 500 text messages. If we just put it as is, that is going to be charging us for the 500 text messages twice. So in order to actually fix this, what we need to do is we need to subtract the 500 text messages that are included with the base plan so that we're not counting them twice when we actually start using the second formula. And that does it. You can also simplify that equation, but for our purposes, that's good enough. Not all of piecewise functions, when you're talking about word problems, require you to write an equation like this, but this particular one does.
Okay, so in this video, I'm just going to wrap up by going over a way to write this equation algebraically, because again, sometimes it's not always practical to try to extend that line. So having the algebraic way as a backup is helpful. So to do it algebraically here, we can either use y equals mx plus b, the slope-intercept form of the linear equation, or we could use point-slope form, which is y minus y1 equals m times x minus x1. I'm going to choose to use y equals mx plus b if for no other reason than the fact that it's a lot easier for people to remember. So that's really why I'm going to use that, is just because people have an easier time remembering that version of the equation. So if I go ahead and use this, we're going to find slope, same as it was before. We could have done rise over run. We could have done y2 minus y1 over x2 minus x1. But we already found slope earlier. We found that slope was 1. Just doing rise over run came out to be going up 4 and over 4. Okay, so slope found. Found it earlier. We're just going to stick with it. Now that we know slope, we're going to use slope and a point to help us figure out the y-intercept algebraically, because again, extending the line isn't always practical. So, I'm just going to use this point here. It doesn't matter which point I choose. I'm going to use 1, 4. And what I'm going to do is I'm going to plug everything I can into the y equals mx plus b, and then solve it for b. So, our y value from our order pair is 4, so we're going to have 4 equals, my slope is 1, the x value from my order pair is 1, plus b. Simplify the equation, 1 times 1, so 4 equals 1 times 1, which is 1, plus b. Solve for b, subtract 1, subtract 1. B is equal to 3, so my y-intercept is 3, and my equation is y equals 1x plus 3, which, as you can see, is the same thing as what we found earlier by extending the graph. And of course, extending the graph is not always practical, but it is a lot quicker and simpler if it's a doable option. If not, here's the algebraic way of going about it.